Assalamualaikum warahmatullahi wabarakatuh to all of my students. Inshallah, today we will go through tutorial 5, phase equilibria, where we already learned this topic, this chapter in our previous lesson. So today we will go through all the questions that I already prepared for you, and I hope that all of you had answered this question before. So in order for you to have a full understanding or get more from this lesson, I'm already designed all the questions to complement my lecture. So I hope that all of you can have more understanding regarding this topic. So in this tutorial, I already prepared 6 questions for you, where my tutorial will cover only 5, where the last question, I hope that you can answer it by yourself and discuss among your friends. So let's look at the first question. Gives free energy G, delta G combines enthalpy and entropy into a single value. The change in free energy delta G is equal to the sum of the enthalpy plus the product of the temperature and the entropy of the system as per equation 1. Given equation 1, delta G equal to delta H minus T delta S, where delta H is the enthalpy, T is entropy, and T is temperature, and delta S is the entropy. That is the definition of the equation. For your opinion, is it possible that you can predict the spontaneity of a chemical reaction? Justify your answer. Okay, so we know that we can use this equation to predict the given energy of the reaction by providing all the definition and value of delta H, T, and delta S. By giving the all definition of enthalpy, temperature, and also entropy, we can get the value of delta G. So the value obtained, either is positive or negative, will determine the spontaneity of a chemical reaction. Where if we get negative value of delta gives energy, so we can get it is spontaneous. Where if we have a positive value of the given energy, so it means our chemical reaction is not spontaneous. So you can refer to my previous slide. So you can refer to this and try to understand better about this given energy, because it is very important. It's very important to make sure that we know about this given gives energy, because it is the chemical equation that we will use in chemistry, because the delta G indicates the spontaneity of a reaction, and from there we can derive a lot of equation from there by given a certain condition, and also by given certain condition at regarding the environment of the chemical reaction. So next, let's move to equation 2 by using following equation. Delta GM is delta molar Gibbs energy equal to VM, that is molar volume, delta P is difference in pressure, and delta GM equal to GM in bracket PF minus GM in bracket PI. So it means that delta molar Gibbs energy equal to molar Gibbs energy at final pressure minus molar Gibbs energy at initial pressure. So the question asks us to prove molar Gibbs energy at the final pressure equal to molar volume at a final pressure minus initial pressure plus molar Gibbs energy at initial pressure, and try to explain the information that we can obtain from our answer in 1A. So to answer this question, so this is about the mathematical chemistry. So if we refer back to our previous subject that I talked you about the mathematical chemistry, it's about how we substitute or we are using the chemical reaction to get another, by using mathematical equation to get another mathematical equation, by using a substitution method. So first of all, we need to have this equation first. Okay, so we label it as equation 1. So from there, we need to see what can we do later, and we know that delta P is a differences in pressure. What is difference in pressure? So we can say that it is a final pressure minus initial pressure. You can label it as P2 minus P1 or P3 minus P2. It depends on you, but because of our question asks us PF minus PI, so try to stick or try to have a look at what our equation wants us to do. So we stick at this definition, final pressure minus initial pressure. So next, and we label it to equation 2. And next, what we need to do is we insert equation 2 to equation 1. So just replace or substitute delta P with our definition. So we will have delta Gm equal to Vm in bracket Pf minus Pi. So, and then we can take another relation. This is another relation where delta molar Gibbs energy equal to molar Gibbs energy at final pressure minus molar Gibbs energy at the initial pressure. So we label it as equation 4, and then we try to insert equation 4 to equation 3. We just replace this delta Gm with this one, and then we will have, this equation, and then try to rearrange it. We can get molar Gibbs energy at a final pressure equal to molar volume in bracket final pressure minus initial pressure plus molar Gibbs energy at initial pressure. So we already proved how to get this equation, and next the question asks us to explain all the information that we can obtain from our answer to A. So from our equation, if we look at the equation, we can state that molar volume will always have positive value, because volume, when we talk about volume cannot be negative. So if we have positive value here, try to substitute any number here. So we can state that the Gm will be more than 0. So as our volume increase, the Gm will be increased too. And as our, besides, we can state that if P increase, if delta P more than 0, it means that P final is more than 0. Although the value of P final is larger than P initial, so it will make the delta P is more than 0. our GM, our molar energy will be increased too. And the volume, the molar volume of gas will be more than liquid, and the molar volume of liquid will be more than solid. So thus, the molar Gibbs energy is very, very dependent on the pressure, especially for gas. And if you want to prove it graphically, you can have a graph looks like this, and from here you can state that at the low pressure the gas phase is the most stable, while at the higher pressure the liquid phase is more stable, followed by solid phase. So here is the graph if you want to prove it experimentally, or you want to extract information from it. So when we rearrange the equation that we have before, so it will look like this, and we know that we can turn the equation and it will look like y equal to ms plus c. This is a linear equation. While if we have gas, we need to relate it with ideal gas equation, where we need to replace the molar volume with RT, with Riemann equation, temperature, and we need to introduce a known factor here. Now let's look at equation 3. By using following equation, delta Gibbs and delta Gibbs. By using the following equation, delta molar Gibbs energy equal to molar entropy delta T, and delta molar Gibbs energy equal to molar Gibbs energy at the final temperature minus molar Gibbs energy at the initial temperature, and try to prove molar Gibbs energy at final temperature equal to molar entropy at, in bracket, final temperature minus initial temperature plus molar Gibbs energy at initial temperature, and try to extract the information we can obtain from our equation in 3b. So, and again, it is a mathematical formula, analysis of mathematical equation related to chemistry subject. So we need to use mathematical works to work out with this equation. So we have this equation from our this equation from our equation. So we have delta molar Gibbs energy equal to minus molar entropy delta T. We know that delta T is the definition of delta T is final temperature minus initial temperature, and we can substitute this equation to the first equation by definition, and we will have delta molar Gibbs energy equal to minus molar entropy in bracket final temperature minus initial temperature, and then later on we will take another definition, which is delta molar Gibbs energy equal to molar Gibbs energy at the final temperature minus molar Gibbs energy at the initial temperature, this one, and we try to include it to this our equation here, equation 3. And then we can rearrange it, and we will have our final equation. And from the equation, we can state that if our molar entropy have positive value, there will be an increase in temperature where delta T is more than 0. The result will be a decrease in GM. So if we have our SM have positive, so we try to make it positive, try to put a value here. So we will meet this condition, our delta GM will be less than 0. And also at a given change of temperature, the change in molar Gibbs energy is proportional to